Hello everyone, today we're going to be covering the Wireshark Packet Operations premier move from TryHackMe. We're going to learn the fundamentals of packet analysis with Wireshark and how to find the needle in the haystack. So with that being said, let's get started with task 1 introduction. And I've already started up the virtual environment to save some time. So with that being said, in this room, we will cover the fundamentals of packet analysis with Wireshark, yay, and investigate the event of interest at the packet level. Note that this is the second room of the Wireshark room trio, and it's suggested to visit the first room, Wireshark the basics, to practice and refresh your Wireshark skills before starting this one. So you can see here, open link in new room, which I've done. Nice. Alright, Wireshark the basics. If you haven't heard or have used Wireshark before, this is an excellent resource to do that. It's a premium room, so you're going to need a subscription or max, so just keep that in mind. But overall, this room just really helps you better understand, like, foundationally, what is Wireshark? Wireshark is an open source, cross-platform network packet analyzer tool capable of sniffing, investigating live traffic, and inspecting packet captures PCAP. It's commonly used as one of the best packet analysis tools, and in this room, we will look at the basics of Wireshark and use it to perform fundamental packet analysis. And here are the learning objectives here. And so overall, if you haven't used Wireshark before and you want to get a better understanding of it, this is an excellent resource to help you better understand and overall become familiar with Wireshark. Additionally, the other prerequisite is networking fundamentals. It's a module, and it's going to help you better understand foundational and overall fundamentally important networking concepts, computer networking, so that way you better understand these concepts to help you better understand what is covered in the Wireshark rooms. So I highly recommend checking these out. These are super fun and just overall filled and packed with really great information, and it's going to help you better understand computer networking. Alright, now environment. A VM including Wireshark and multiple packet captures is attached to this room. We can start the VM by clicking on the Start Lab Machine button below, which we've done, and the lab machine will start in split view. If you don't see the VM in split view, you can click on the blue Show Split View button at the top right of this room page to show it. So we're going to open the exercise.pcap.eng file on the desktop and follow along. And note, do not directly interact with any domains and IP addresses in this room. The domains and IP addresses are included for reference reasons only. Also, in case I haven't mentioned it, hello, my name is Dr. Speedshock. I'm a cybersecurity analyst and Blue Team content creator. So let's get started with exercise.pcap.ng file and overall complete the tasks. This is going to be fun. Alright, statistics, summary. What is statistics? Not math. This menu provides multiple statistics options ready to investigate to help users see the big picture in terms of the scope of the traffic, available protocols, endpoints, and conversations, and some protocol-specific details like DHCP, DNS, and HTTP2. For security analysts, it is crucial to know how to utilize the statistical information. This section provides a quick summary of the process PCAP, which will help analysts create a hypothesis for an investigation. You can use the statistics menu to view all available options. Now, with that being said, start the given VM, open the Wireshark, which we have done, load the exercise.pcap.ng file, and go through the walkthrough. Yay! Alright, resolved addresses. This option helps analysts. Let me pull it up. Here you go. This option helps analysts identify IP addresses and DNS names available in the capture file by providing the list of the resolved addresses and their host names. Note that the host name information is taken from DNS answers in the capture file. Analysts can quickly identify the access resources by using this menu. Thus, they can spot access resources and evaluate them according to the event of interest. You can use the statistics resolved addresses menu to view all resolved addresses by Wireshark, which we can see here. Now, protocol hierarchy. This option breaks down all available protocols from the capture file and helps analysts view the protocols in a tree view based on packet counters and percentages. Make it easier on the eyes by making it full screen. Widen. There we go. Thus, analysts can view the overall usage of the ports and services and focus on the events of interest. The golden rule mentioned in the previous room is valid in this section. You can right-click and filter the event of interest. Which we can see here, right-click and apply as filter. And to get here, you can use statistics, then protocol hierarchy, and you will see this information. Awesome. All right, conversations. Conversation represents traffic between two specific endpoints. This option provides the list of the conversations in 5 basic formats: Ethernet, IP version 4, IP version 6, TCP, and UDP. Thus, analysts can identify all conversations and contact endpoints for the event of interest. You can use the statistics conversations menu to view this info. Now, let's move on to endpoints. Minimize this. Cool. The endpoints option is similar to the conversations option. The only difference is that this option provides unique information for a single information field: Ethernet, IP version 4, IP version 6, TCP, and UDP. Thus, analysts can identify the unique endpoints in the capture file and use it for the event of interest. You can use the statistics endpoints menu to view this info. Also, Wireshark also supports resolving MAC addresses to human immutable format using the manufacturer name assigned by IEE. Note that this conversion is done to the first 3 bytes of the MAC address and only works for the known manufacturers. When you review the internet endpoints, you can activate this option with the name resolution button in the lower left corner of the endpoints window. Nice. Also, name resolution is not limited only to MAC addresses. Wireshark provides IP and port name resolution options as well. However, these options are not enabled by default. If you want to use these functionalities, you need to activate them through the, let's do that, Edit, Preferences, Name Resolution menu. We have it right here. Once you enable IP and port name resolution, booyah, you will see the resolved IP address and port names in the packet list pane here. And also, we'll be able to view resolved names in the conversations and endpoints menus as well. Really handy. Alright, besides name resolution, Wireshark also provides a geolocation mapping, IP geolocation mapping, that helps analysts identify the map source and destination addresses. But this feature is not activated by default. It needs supplementary data like the GeoIP database. Currently, Wireshark supports MaxMind databases, and the latest versions of the Wireshark come configured with the MaxMind DB resolver. However, you still need MaxMind DB files and provide the database path to Wireshark by using the Edit, Preferences, Name Resolution, MaxMind Database Directories menu. And once you download and indicate the path, Wireshark will automatically provide GeoIP information under the IP protocol details for the matched IP addresses. You can see here. And note, you need an active internet connection to view the GeoIP map, and the lab machine doesn't have an active internet connection. So all this information, let's go answer some questions. Alright, first, investigate the resolved addresses. What is the IP address of the host name that starts with BBC? And we have a hint. Resolved addresses can help. So let's go to statistics, resolved addresses, type in BBC, and we got our IP address 199.232.24.81. Nice. Alright, next. What is the number of IP version 4 conversations? Conversations can help. Pun intended. Alright, conversations. Now, IP version 4. We got 435. Yay! Alright, next. How many bytes, K, were transferred from the micro ST MAC address? Hint. Endpoints and name resolution can help. So let's go to endpoints. We have name resolution. There we go. And we're going to try to find the micro ST MAC address. So scroll macro ST. There we go. And our bytes was 7474K. Type 7474. Alright, they're gonna use young eyes. Nice. Alright, what is the number of IP addresses linked with Kansas City? Hint. Endpoints can help. Points. Ethernet. IP addresses linked with Kansas City, I believe. Name resolution. TCP. Version 4. So they want okay. So they want IP addresses, IP version 4, and IP version 6. Okay, none for IP version 6. So we're gonna go IP version 4. Cool. All right, let's go find Kansas City. So let's go look for city. Find Kansas City. It's gotta be here somewhere. Go find it. Scroll all the way down. Vegas, Angeles. Copy. Alright, now I got it. I believe alphabetical order. Alright, cool. United States, Kansas City. There we go. How many IP addresses are there? There is. So these 4. 1, 2, 3, 4. There's 1, 2, 3, 4. I believe 4. Nice. Alright, which IP address is linked with BlickNet AS organization? Endpoints can help. We're here. Look for AS. AS organization. Let's go look for BlickNet. I think I pronounced that right. Alright. B. Net AS. AS. Alright, BlickNet. And the IP address is going to be named. It's going to be. Alright, there you go. 246.82.7. Nice. Alright, now moving on to the statistic protocol details. IP version 4 and IP version 6. Up to here, almost all options provide information that contain both versions of the IP addresses. The statistics menu has 2 options for narrowing the statistics on packets containing a specific IP version. Thus, analysts can identify and list all events linked to specific IP versions in a single window and use it for the event of interest. You can use the statistics IPv6 statistics menu to view this info. So we can do, let's get out of endpoints, statistics IPv6. And we can see the information right here. To this info. So let's just say I want IP protocol types. And I should see, yes, count, average, much more. Nice. Alright, now DNS, domain name system. This option breaks down all DNS packets from the capture file and helps analysts view the findings in a tree view based on packet counters and percentages of the DNS protocol. Thus, analysts can view the DNS service's overall usage, including R code, opcode, class, query type, service, and query stats, and use it for the event of interest. You can use statistics, DNS menu, right here, to view this info. Very neat. Alright, now HTTP. This option breaks down all HTTP packets from the capture file and helps analysts view the findings in a tree view, right here, including the request and response codes and the original responses. You can use the statistics HTTP menu to view this info. So we got packet counter, requests, load distribution, and we got request sequences. Right here. Packet counter, request, load distribution, and request sequences. Alright, now what is the most used IP version for destination IP address? And we got a hint. IP version for statistics can help. So we're going to go to IP version for statistics. And we're going to find all addresses. It's going to give us a count. We want most, so descending. It's going to be 10.10. 10. What? Oh, destination. So wouldn't it be this one? Hold up. Statistics. IP version 4. Source and destination IP addresses. I got source. And now where's destination? Alright, let's go to destination IP addresses. And I can just count. There we go. 10.10.57.178. But we want the Ivory version for destination address. Gotta scroll down. Destination is going to be 10.100.1.33. We've got destination IP version for addresses, and we stored it by count. And the most used IP version for destination address is going to be this one. All right, now what is the max service request response time of the DNS packets? So DNS statistics can help. This is fun. All right, statistics, DNS, service request response time, service request response time. Right. Response time. Is it burst rate? Is it this one? Oh, request response time, count, average, min value, max value. It's going to be 0.467897. Nice. All right, what is the number of HTTP requests accomplished by raid.msn.com? So the number of HTTP requests by raid.msn. And we see that there's a lot. So the count is going to be, we got 39. Let's go see it. 39. Nice. And how I got the answer was ray.msn.com, and then I scrolled all the way to the right and count 39. Alright, now packet filtering principles. In the previous room, Wireshark Basics, which I highly recommend checking out, and also I'll probably do a walkthrough on that later, we covered packet filtering and how to filter packets without using queries. In this room, we will use queries to filter packets. As mentioned earlier, there are two types of filters in Wireshark. While both use similar syntax, they are used for different purposes. So let's remember the difference between these two categories. So starting off, let's talk about capture filters. This type of filter is used to save only a specific part of the traffic, and it is set before capturing traffic and not changeable during the capture. On the other hand, display filters. This type of filter is used to investigate packets by reducing the number of visible packets, and it is changeable during the capture. Note, you cannot use the display filter expressions for capturing traffic, and vice versa. The typical use case is capturing everything and filtering the packets according to the event of interest. Only experienced professionals use capture filters and sniff traffic. This is why Wireshark supports more protocol types and display filters. Now please ensure you thoroughly learn how to use capture filters before using them in a live environment. And remember, you cannot capture the event of interest if your capture filter is not matching the specific traffic pattern you're looking for. Awesome advice. Now the capture filter syntax. These filters use byte offsets, hex values, and masks with Boolean operators. Please go of it. And it is not easy to understand predict the filter's purpose at first glance. The base syntax is explained below, such as we have the scope, the direction, the protocol, and the sample filter to capture port traffic right here. You can read more on capture filter syntax from here and here in here. So for PCAP filters, nice, and more capture filters. This is awesome. Awesome. And a quick reference is available under the capture and capture filters menu. Alright, now display filter syntax. This is Wireshark's most powerful feature. It supports 3,000 protocols and allows conducting packet level searches under the protocol breakdown. The official display filter reference, which we can see here. Let it load. Oh, this is awesome. So good. And that's why Wireshark has a certification. I'm bookmarking this website. Nice. Alright, what this website does is it provides all supported protocols breakdown for filtering. Example, sample filter to capture port 80 traffic, TCP.port 80. And Wireshark has a built-in option. Display filter expression that stores all supported protocol structures to help analysts create display filters. We will cover the display filter expression menu later. Now, let's understand the fundamentals of the display filter operations. A quick reference is available under the Analyst, Analyze, Display Filters menu. Nice. Now, comparison operators. You can create display filters by using different comparison operators to find the event of interest. The primary operators are shown in the table below, such as equal, EQ, NE, GT, not GTA, LT, GE, and LE. Note, Wireshark supports decimal and hexadecimal values in filtering, and you can use any format you want according to the search you'll conduct. Now, logical expressions. Wireshark supports Boolean syntax. You can create display filters by using logical operators as well, which we can see here. Very nice. And our packet filter toolbar. The filter toolbar is where you create and apply your display filters. It is a smart toolbar that helps you create valid display filters of ease. And before starting to filter packets, here are a few tips. First, packet filters are defined in lowercase. Second, packet filters have an autocomplete feature to break down protocol details, and each detail is represented by a dot. And third, packet filters have a 3-color representation explained below. Green is a valid filter, red is invalid, and yellow is a warning filter. This filter works, but it's unreliable, and it suggests to change it with a valid filter. Here's some filter toolbar features shown below as well. Nice. So you got view filter history, clear filter. There we go. Autocomplete, see options, and bookmarks. Awesome. All right, so we've covered lots of principles and syntax. Let's put this into practice and start filtering packets in the next text. Nice. Alright, so protocol filters. As mentioned in the previous task, Wireshark supports 3000 protocols and allows packet level investigation by filtering the protocol fields. This task shows the creation and usage of filters against different protocol fields. And IP filters help analysts filter the traffic according to the IP level information from the packets network layer of the OSI model. This is one of the most commonly used filters in Wireshark, and these filters filter network level information like IP addresses, version, time to live, type of service, flags, and checksum values. And the common filters are shown in the given table below. IP, show all IP packets. This, show all packets containing IP address 10.10.10.111. This shows all packets containing IP addresses from 10.10.10.0/24 subnet. And IP.src equals show all packets originating from 10.10.10.111. And IP.dst destination equal 10.10.10.111. Show all packets sent to 10.10.10.111. Now, in IP.addr versus IP.src and IP.dst. Note the IP.addr filters the traffic without considering the packet direction. And the IP.src IPDST filters the packet depending on the packet direction. We also got some TCP and UDP filters. Lots of awesome information. Alright, what TCP filters do is that it helps analysts filter the traffic according to protocol level information from the packets transport layer of the OSI model. And these filters filter transport protocol level information like source and destination ports, sequence number, acknowledgement number, window size, timestamps, flags, length, and protocol errors. We can see some examples below. Nice. Really nice demo. Sweet. Now, application level protocol filters, HTTP and DNS. So now, application level protocol filters help analysts filter the traffic according to application protocol level information from the packets at the application layer of the OSI model. And these filters filter application specific information like payload and link data depending on the protocol's type. I'm seeing some examples here. This is awesome. Alright, now display filter expressions. As mentioned earlier, Wireshark has a built-in option, display filter expression, which we can capture, analyze. There we go. Nice. That stores all supported protocol structures to help analysts create display filters. When an analyst can't recall the required filter for a specific protocol or is unsure about the assigned values for filter, the display filter expressions menu provides an easy-to-use display filter guide, filter builder guide. So an example, let's use the one provided. So you want IP dot field name, IP dot P, IP.protocol. Destination. And we can see here the relations and the values and much more. Display filter. This is super handy. Alright. Because overall, if you wanted to get a better understanding of a required filter for a specific protocol or the assigned values for a filter, this menu provides an easy to use display filter builder guide, and it is available under the Analyze Display Filter Expression menu. Also, it is impossible to memorize all details of display filters for each protocol. Yes, there's a lot of them. The Display Filter Expressions menu shows all protocol fields, accepted value types, integer or string, and predefined values, if any. Note that it will take time and require practice to master creating filters and learning the protocol filter fields. So there you want IP, they're lowercase, IP address here, and much more. Nice. Our note: the Wireshark's basics introduced the coloring rules test 2. Now you know how to create display filters and filter the event of interest. You can use the view coloring rules here to assign colors to highlight your display filter results. Alright, so let's go answer some questions. We get a lot of questions. It's gonna be fun. Alright, what is the number of IP packets? So we want to find the number of IP packets. Go to statistics. All addresses. I believe it's going to be 81,420. Nice. Alright, what is the number of packets with a TTL value less than 10? I believe TTL, that's going to be DNS. Let's go to statistics. DNS. Go to packets. TT. Let me just check. Packets. And 1 second. What is the number of packets TTL value? List. Then 10. I want to double check my logic just in case I'm missing something. Alright. But we are making awesome progress. Alright, task 5. We want to find TTL. Okay. So what we want to do is close out of this and display filters, because we're talking about display filters, IP dot TTL. Right here, auto correct, TTL less than 10. And the number of packets that we have is 66. Nice. Now, what is the number of packets which uses TCP port 444? So in this case, we want to filter by TCP. So we're going to put in this filter, TCP that port equal 4444. And we got 632. Nice. Alright, now what is the number of HTTP GET requests sent to port 80? So we're going to use application level filters, not level layer. Did not hear that. Okay, so HTTP dot request method. So what method equal get, and I believe they also want port sent to port 80. I believe that is going to be and TCP dot port equal 80. And we got 527. Nice. Now, what is the number of type A DNS queries? And we have a hint. Don't forget to filter out the LMNR queries. So what that is that we are going to use this filter to show all DNS A records. DNS.query.type equal 1. So let's do that. That's clear. DNS.query.type equal 1. And the answer is going to be actually 106, but it wants 1. Show all DNS records. Let's try a different approach. Let's do analyze, then display filter expression. Then let's scroll down to DNS. So D N D O. DNS. All right, DNS domain name system. Get DNS.A. So let's try this one. Okay. And we got 51. So now we can see DNS addresses, DNS information, but they are of the A record. So the number is going to be 51. Now, advanced filtering. Advanced filtering. So far, you have learned the basics of packet filtering operations. Now it is time to focus on specific packet details for the event of interest. Besides the operators and expressions covered in the previous room, Wireshark has advanced operators and functions. These advanced filtering options help the analyst conduct in-depth analysis of an event of interest. For example, filter contains. Need to type is comparison operator, description, search a value inside packets. Example, find all HTTP, find all Apache servers. And the workflow is to list all HTTP packets where packet server field contains the Apache keyword, which we can see here, and what the output looks like in details. Now matches. We can see type, description. It searches a pattern of a regular expression. Example, find all .php and .html pages. And the workflow is to list all HTTP packets where packets host fields match keywords .php or .html. And usage.http.host matches this. You can see the output. Nice. Now in is type of set membership. Description here is to search a value or field inside of a specific scope or range. Example, find all packets that use ports 80, 443, or 8080. Workflow, list all TCP packets where packets port fields have values 80, 443, or port 8 or 8080. See that here? Nice. Now upper converts a string value to uppercase. Nice. Lower, lowercase. Lower the HTTP server contains Apache. And string. It converts a non-string value to a string, so a string framed at number matches this. Converts all frame number values fields to string values, and this frames end with odd numbers. Alright, now bookmarks and filtering buttons. We've covered different types of filtering options, operators, and functions. It is time to create filters and save them as bookmarks and buttons for later usage. As mentioned in the previous task, the filter toolbar has a filter bookmark section, as you can see here, to save user-created filters, which helps analysts reuse favorite complex filters with a couple of clicks. Very nice. Similar to bookmarks, you can create filter buttons ready to apply with a single click. So to create and using bookmarks can be found here. Really awesome. Awesome. And creating using display filter buttons, add this. We can make it odd frames. And if you wanted to use this filter, you can just click it and you can play the filter. Super handy. Alright, now profiles. Alright, profiles. Wireshark is a multi-functional tool that helps analysts to accomplish in-depth packet analysis. As we covered during the room, multiple preferences need to be configured to analyze a specific event of interest. It is cumbersome to change the configuration for each investigation case. It requires a different set of coloring rules and filtering buttons. This is where Wireshark profiles come into play, and you can create multiple profiles for different investigation cases and use them accordingly. You can use the Edit Configuration Profile or the lower right button of the status bar profile section to create, modify, and change the profile configuration. Let's see here. And create. And also we can do configuration profiles. Nice. Alright, now let's go answer some questions. Find all Microsoft IIS servers. And what is the number of packets that does not originate from port 80? Give a hint. It contains operator can help. Cool. So I believe. Alright, let's see. There's a lot of filters, so let's go get some hands-on practice. Alright, so since we're talking about servers, let's see if this works. Let's do HTTP server, and we're going to do contains, IIS, and TCP. Since we're talking about originate, we're talking about source port, .src port not equal to 80. And source port. Where am I missing? Let's see. And I got 21 as my answer. Let's see if that works. Nice. Alright, now find all Microsoft IIS servers and what is the number of packets that have version 7.5. So let's remove this. Let's go look at IIS servers and try to find version 7.5. So servers, I believe, going to be in where? X. Oh, server Microsoft IS. It's gonna be a high, so it's gonna be in there. Okay. All right. What's the hint? Matches operator can help. All right. So since we're talking about HTTP, let's see if we can also do and HTTP dot server, because this is a server, and let's do contains 7.5. And we got 71. So now we can see servers that have version 7.5 right here. Nice. So our answer is going to be 71. That should be right. Nice. Music to our ears. And now, what is the total number of packets that use ports 333, 444, or 9999? An operator can help. So I believe these are all TCP. They should be, I think. So let's try TCP dot port. Oh, they want in operator. So let's go see what that does. So I want in string port. So that's TCP port in, and the ports that we want is 3333, 4444, 9999, and total number of packets is going to be 22 through 2235 displayed. 5. Nice. And what is the number of packets with even TTL numbers? String match operators can help. Convert the TTL field to string with the string operator, then filter by that regex value for even numbers. With the matches operator to find the even TTL numbers. Okay. So, since we're talking about TTL, let's break it down. And TTL is a number. So let's see. String and matches operator can help. So string. Let's go with IP. IP. That's TL. There we go. And then I believe it's matches. Yes, matches. And then even numbers. 0, 2, 2, 4, 6, 8. It ends. Does it want ends? I believe it does. And I got 77,289. And cool. Sweet. Ethernet. TTL. That's in here. Alright, cool. Now, what is the number of packets even TTL numbers? It is going to be, let's see if this works. 77,289. Sweet. String IP.ttl because we're looking for TTL. And our even numbers 022468. And then money. And now change the profile to checksum control. And what is the number of bad TCP checksum packets? Alright, this new profile is customized to detect checksum errors. Bad TCP checksums are shown in red and black colors. We're going to use the packet list pane details or the display filter expression menu to create the required filter. So to do that, let's go to Edit, Configuration Profiles, Checksum Control, hit OK. And I got 80. Oh, back. Bad TCP checksums are shown in red and black colors. So we're going to need to change it up. Now let's go to Analyze, Expert Information. And then we got, because we wanted to see display filter expression menu to create the required filter. Shown in red and black colors. And so we want the number of bad TCP checksum packets. So that's going to be... Alright, I'm going to need to do math. Or never mind, they added all up. Nice. So it's going to be... Let's go with 34,185. Or next. Now use the existing filtering button to filter the traffic. What is the number of displayed packets? So to do that, we need to click this filter button. Okay, let me make this bigger so that it's easier to see. Right here. And let me that. Now what's the number of displayed display packets? So what we want to do is click on this to get our answer. And it's going to be 261. Nice. Sweet. We learned a lot in this section. We learned about profiles, which we can see. You can create multiple profiles for different investigation cases and use them accordingly, which we can see here. And how to edit them. We learned about bookmarks and filtering buttons. The filter toolbar has a filter bookmark section to save user-created filters, which helps analysts reuse favorite complex filters a couple of clicks. And similar to bookmarks, you can create filter buttons ready to apply with a single click. As you can see here. How to create and use display filter buttons. The instructions and overall screenshots are displayed here. How to add a display filter button. How to name it. Comment and filter. It shows up, and when you click on it, you get to see the filter, and you get to apply it and all that good stuff, and much more, like filter lower, upper, in, matches, and contains, and a bunch of really good stuff. Awesome. Alright, now task 7 conclusion. Congratulations! You just finished the Wireshark Packet Operations room. Yay! In this room, we covered Wireshark statistics, filters, operators, and functions. Want to learn more? Of course we do. We invite you to complete the Wireshark Traffic Analysis room to improve your Wireshark skills by investigating suspicious traffic activities. We can proceed to the next room and keep learning. So let's hit check. Please task, points earned, and streak. And I can share this on LinkedIn. And learners. Much more. Awesome. Alright. Back. Awesome. And let me do that. Terminate machine. Nice. Alright. I hope you enjoyed my Wireshark Packet Operations Premium Room walkthrough. We learned the fundamentals of packet analysis Wireshark and how to find the needle in the haystack. Hope you guys have a great day and keep up the great work. And I will see you guys for the next walkthrough. Peace.